A servo motor is designed for precise position control, which is what makes it different from a regular DC motors that just spin continuously instead of rotating freely. A servo can be told exactly where to move and hold its position within a limited range, commonly 0 to 180. Servo works inside the servo motors. There are three main parts. DC motor provides the movement, and the gear system reduces speed and increases torque or discharge. And the third is the control circuit. Potentiometer tracks and control the exact position. Example position explained: a zero full close. The servo shaft rotates to its minimum position. This might mean a robotic arm is fully down or a valve is shut. A 90 degrees is a halfway. This is the center position. May project start the servo here in a neutral point. And the lastly is the 180 degree. 180 degree is a fully open. The shaft rotates to its maximum position. For example, a door mechanism would be fully open. These laboratory activities show how an IoT system works locally by connecting an ESP32 microcontroller to a computer server using Wi-Fi. The ESP32 acts as data gathering device while the computer running SAM acts as the server that receive, processes, and store the data. How the system will work, the process following as a simple chain. The ESP32 collects or generate data, example the temperature and the humidity. It connects to Wi-Fi and send the data using the HTTP request or the post method. The request goes to a local server running on a computer using the XAMPP, uh, which is the Apache, and the server uh, receives the request. Then the PHP script process the data. The processed data is stored inside the MySQL. The stored data can be viewed later in a browser using a PHP page. In short, the ASP32 sends data and the server receives it, then PHP process it in, and then MySQL store it, then browser display it. So what's the purpose? The purpose of this laboratory is the main purpose of this activity is to understand how our device communicate with web servers, learn how it's sent using HTTP requests, practice storing real-time data in a database, build a simple monitoring system using local tools, demonstrate how IoT system work without using the cloud service. This is basically in a mini version of real IoT system used in a smart homes, weather station or industrial monitoring. The hardware we need is the ASP32 development for board, the this is the main IoT device that sends data. Then also we need the USB cable to for the programming and the power also of the ESP32. Then of course we need a laptop or a desktop computer, but also in our activities we are using laptop for runs the server. And then also we need Wi-Fi for communication between ESP32 and the server. Mm. Each component is important because ESP32 it collects and sends data wirelessly, and the XAMPP turns your computer into a local server, and the PHP connects to into ESP32 to the database, and MySQL stores the data permanently. Wi-Fi network allows communication between devices. Um, This teaches how a real IoT system works by showing a sensor device ESP32 can send data over Wi-Fi to a server where processed and stored in a database. for later viewing and analysis. Records form. Then dito may sa Arduino kailangan natin install yung SP8266. Yan. Gumagana naman na siya. Ayan yung code, sir. Then, yan na yung output niya sa pag pinili natin yung link sa localhost. Then, yun na yun. Yan yung code, sir. In this activity, hardware tools and purpose. We need the tools is the ESP32, which is the main controller or the brain of the system. Reads input from keypad, sends username, password to server, receive response, access granted and denied. And also, the tools is or the hardware is breadboard used to build the circuit without soldering holes to components and connection temporarily. And also we need jumper wires connects components together, links ESP32 keypad and display. Keypad matrix. This is the input device. Users enters the username or the password. LED display. This will be the output device. Show message like access granted or access denied. In the software is also we need a Wi-Fi for the ESP32 tools, and in the software with the SAMP local server environment runs the whole system on your computer. Apache HTTP server handles the request from ESP32 receive login data, and it's also the PHP process login logic, check if the username and the password are correct. PHP manage the database easily used to create user accounts, and also we need the MySQL stores login credentials, contains username and the passwords, overall the purpose of the system, and also this project creates a simple login application system where user enters username using keypad. ESP32 sends the data to the server. PHP checks the database for the MySQL server sends back results. In the LED display shows if the username and password is correct, then it is display access granted. Then if wrong, the display shows access denied.